Good morning, Naveen. So I think today we have both of you, Naveen and Shubhankar. I think yesterday, I believe you all were not there, na, for the class. Okay, so quick recap. So good morning, and we kind of yesterday continued our discussion, and we recapped whatever we discussed. So as I said, we had these different frameworks which we went through. The 5W1H framework. We took one more case example, caselet. Typically, this is how it will be asked in your end term also, that you'll be given a caselet and you'll have to do the breakup of the problem and understand the problem in more detail, for which you'll have to look at the 5W1H framework to give you help you in the questions on the specific aspects of what, who, where, when, why, and how. Right. So these things we discussed, and the 5C framework is another way of looking at hypothesis formulation, because the why question is where hypothesis becomes important, because when you have to explain why something happened, and especially it's the problem, and you're trying to arrive at a cause effect kind of thing, you need to have some probable alternative scenarios which you might want to explore. And that is the whole idea behind this data analytics, that you have a problem or you have a certain thing which you want to understand, for which you need to define the problem properly, and then go about testing all the different scenarios and then validating what you find and rejecting what you don't find. So that's the basic methodology which is adopted in any kind of a data science project, right? And the idea is that we use the tools and techniques which are provided to us from statistics or machine learning to help us arrive at our insights. And so we had a discussion also around this business intelligence and business analytics, and what is the context in terms of, are they similar or are they different? And essentially, we said that the business analytics, business intelligence was the earlier generation of analytic solutions which were deployed in companies where the focus was more about visualization, dashboards, scorecards, reports, OLAP reports, and more about summarizing the data which has been there in the past. Now, what we have seen is that with a lot of these data mining algorithms, which are basically coming under the supervised and unsupervised learning, we have a much powerful toolkit in terms of how to make your decisions better, because now you can use these algorithms to arrive at a certain decision which is based on the statistical and analytical model which it has built into it, whether it's a neural network model or it is a classification regression tree model or it's a logistic regression model. So as long as you have taken care to ensure that you have given the right data, you have identified the right variables, the model will give you the results, and your explanatory power is determined by the model's values, what you get. And then you have to just try to ensure that your models get better over time, which means that you refine the model and include more variables or drop some variables or predictors, as they call it in the machine learning data science world. So variables is a term which we use in statistical context, that there's an independent variable, dependent variable, and other types of variables. When we go into the computer science, then they don't talk in terms of variables, they talk in terms of predictors, right? Which is basically the same thing as the independent variables or influencing variables, which affect a certain predictive model. All right, so that was a bit of discussion. So we have to just wrap up our this thing, because now the next two classes, that is today and the next class, we are going to basically spend time on Tableau, because your project involves, the first part is the conceptual part, where we have dealt with all these different frameworks and things like that. And then we go into the visualization, which is the fun part, where we actually go to explore the tool and experiment with all the different columns which are your variables, and then try to see what are the patterns you see in the data. Okay, any questions or anything you want to comment on? I believe I can just also unmute. So in case anyone wants to unmute, please go ahead, and you can, you have the unmute. access
Yes.
to speak
Sir, what
so
about
that
the IS,
I
sir?
don't have to check the chat box because there's only three of you all, right, today. 3 to 4. I think it's a small batch, I believe, right? This batch.
Sir, what about the IS, sir, for this particular module?
No, I believe we don't have IA. We have a direct.
Just give me a minute. I'll just
Okay, we
open
don't
one.
have an IS.
We have a
My
project that
Windows. 1 second.
need to be submitted on 23rd July.
So when is that project submission, the window?
23rd July, next Sunday.
23rd July, right? And where do we find that project thing?
I think it is on upgrade, learn.upgrade.com. That
Okay.
portal, on portal.
On the portal itself, okay.
Yeah. Learning portal. When you'll, go with the content now, the last
Yeah.
session would be on the project.
Okay.
So try
Understood.
to complete as soon as possible. So you will go into that window. Okay. Otherwise,
Okay.
it will be locked always, right?
Yeah, got it. Okay, sure. Professor, you're on mute.
This is where we stopped yesterday. We kind of looked at this whole business intelligence, business analytics part, and we kind of try to again go back to this case study, which is our athletics case study, and then we try to see the elements about which ones of them are related to the descriptive part of the project and which is the predictive and which is the prescriptive, because all these three are equally relevant in any project. And we tend to start with descriptive analytics, which is more about helping you to present, get a summary of the current whatever data we have. And then once we have kind of understood the existing data set well, then we start getting into more of either predictive modeling and also, if possible, recommendations, which are more advanced in terms of the kind of impact it creates in terms of the ability to help in decision support. So we just saw the relevant portions of this caselet, which has got a mix of predictive, descriptive, and this predictive, descriptive, and prescriptive analytics. So maybe Sachin, maybe you can just brief your colleagues in terms of what did you understood about predictive, descriptive, and prescriptive analytics.
Yes, sure, sir. There are three parts of business analytics that we saw yesterday. That is, first
Sachin,
part is
are we able to hear you?
It's breaking up,
can
Professor. Kind of, yeah.
you hear me, guys?
Yes, I can hear you.
Now we are able to, yeah.
Yeah. Actually, here raining here. That's why.
No.
We have seen three parts of business analytics yesterday. That is descriptive, predictive, and prescriptive analytics. Our business intelligence starts with descriptive part first. Okay, descriptive part is mostly focused on the past history, or we can say history. Whatever happened in the past, we are trying to present that in the form of reports, dashboards, KPI metrics. So we can say mostly the business intelligence in the past, involves in the descriptive analytics only. But after that, when analytics or data science comes into the picture, uh, it is morely focused on predictive and prescriptive analytics as well. After descriptive, we move into the predictive analytics, where we try to predict the future trends, or you can say
We predict the
supervised
outcome.
learning model. Data science mostly involve the projects of predictive analytics, where we try to find the future trends, or maybe say the forecasting. Sales forecasting could be one of the example of that, or predicting something based on the trends. uh,
So we can say like predictive analysis is something that we predict the outcome and we
Correct.
iterate. We have the iterate of the outcome, iterations, different iterations that we can work out on the outcome on the predictions, and we can forecast uh, what can be the outcome. Again, all of them have the
Correct.
same meaning. Rather, we can say. So we predict the or we iterate our outcomes is what we can say on predictive outcome, right?
Correct. Correct.
Yeah.
Yeah.
Okay.
Yeah. And
Okay.
in later on, the more important part of the business analytics comes, and that is the prescriptive analytics. And prescriptive analytics is one of the, you can say, the outcome of the all both the analytics, that is a descriptive and predictive. Because prescriptive analytics is nothing but providing the solutions, or providing the recommendation, whatever we have derived from the insights for that problem. Correct,
So
sir?
finally, we can say like our prescriptive is the implementation of the predicted solution, which we predicted from the description what has been given.
Excellent, excellent. In fact, if you go back to this case study, which we used for our initial discussion on how the CRISP-DM model was also applicable in this analytics, sports analytics case study. So if you see in this case, right, they have collected already some data about 560 people, records of football injuries which have happened in the past, and they have got different types of predictive variables or variables which are part of the Excel or whatever that data set. So whatever visualizations they have created was to give a good understanding of what is the overall data telling you in terms of what is the type of all these different variables now what they have written here: body part, size, severity. So a summary description in a visual format gives you a very clear kind of a summarized view of what happened and what was the past data looking like. That is the descriptive aspect of this project. The predictive models was the part where they use this to predict that if a particular new case comes, if a new injury comes into that particular data set, based on the algorithms, like in this case, the neural network model, which was used to train on the past 560 records, they can come up with a prediction that how much time it's going to take to recover from this injury. That recovery period prediction is the predictive element of this model, and it had an accuracy of about 80%, which means if you have to if you have to compare this model with maybe the reality, which is that how much actual time that person takes to recover, or if you bring a sports expert, a physiotherapist, a sports physiotherapist, they can tell you how much time it will take. So they can compare this model with the actual recovery time or with the expert advice, and then tell whether this model is accurate or not. So 4 out of the 5 times the model was giving a very good, was giving a accuracy. 1 out of 5 times it misclassified, means that the model might have said that, okay, this kind of an injury with this kind of severity and site and all the other specific variables may go into a 4 to 6 band month, but maybe it might require only 2 to 4 months. So that is a misclassification which has happened because it has misclassified it as a maybe a medium term injury recovery, whereas it required little less time. So those are the ways in which we quantify the extent to which the model is good or bad. And this process keeps getting refined. So we will keep going back to seeing how we can improve this number from 80% to maybe 85%, and so on and so forth. So that misclassification problem, what you might have studied in your statistics as type 1 and type 2 error, is something which we look at it in quantitative terms. And that is the predictive part of the story. And there's also a recommendation which they're saying, right, based on the analysis of business recommendations with regard to how to manage that injury better, how to prevent injuries from happening in the future. That can become a very powerful insight if some players models can generate some analysis which will tell that there is a certain pattern in the injury which we are able to observe, or something like that, then it will give a lot of valuable feedback which can make the lifespan of that player increase a lot, because you know how injuries sometimes take many, in fact, years to recover also. If
Sir,
they
may
are
I
very,
interrupt, sir?
yeah, go ahead, please.
Yeah. Sir, do we have any proper tool that can do a measure of
Yes,
this thing?
all these
So,
tools, if you use Python, there are a bunch of different libraries like stat libraries, and there are a lot of uh, Python packages which have been used for predictive model, for developing recommendation engines. But they are advanced models. It's not going to be very easy to learn it. It takes a lot of time because it's a highly technical kind of a part of the project. So
so what I'm trying to ask
yeah.
is like, for example, me being a business analyst,
Hmm,
okay,
hmm.
I mean, I would not rely rather on going with the Python degree of evaluation, but rather
Right.
I would ask like, do we have any kind of a tools wherein standard or market recommended tools or any client recommended tools wherein we get to have the data, and
Hmm.
once we have the data, can we have any kind of predictions or any kind of prescriptive data based on the analytics that we have? Such kind of tools. For example, I have something called as in Visio. Whenever we try to do some architectural design, they
Hmm.
try to recommend, okay, go with this design or some kind of a template solution that we have. So
Hmm.
such kind of a template solution, do we have any such kind of a tools?
So these tools, as I said, most of them, there are a lot of paid tools which are there. Like for example, if you take SAS, it's a paid tool. You will get SAS
Perhaps
enterprise.
VI
SAS,
visual VI is one among them, Professor.
okay, VI I'm not familiar with. It is the name of the software, VI.
Yeah, so SAS has these products, right? So, for example, DI
Enterprise
and VI.
Miner,
DI is data integrator, and
and VI.
VI is the visual integrator, I believe.
Yeah,
Yes.
visual
So,
integrator. There is another enterprise miner or in SAS, which is the mining tool.
okay,
So
okay.
SAS is a whole product. It's like SAS is one of the oldest companies in this data science space, and they have different, not just libraries, but built-in, ready-to-use, desktop-based applications which can be used for descriptive, predictive, and prescriptive. Ultimately, this is the entire gamut of analytics in the world: descriptive, predictive, and prescriptive. Some people have added a diagnostic analytics also, which is more around root cause analysis. And there are some niche types of solutions for that. But by and large, all companies will try to do a mix of this, either through their own data programmers who are trained in using these libraries in Python, for example, which is really makes it very powerful. But if they are more comfortable using a tool because they don't have people who are trained in these, then they go with these kind of softwares like SAS, which is a paid software. There is a very interesting software called Orange. If I get time, maybe the next class I might show you some demo on Orange, but I don't know if I have that time because Tableau will take up most of our time. But you can explore a tool called Orange. It's built on Python only, but it's a very user-friendly and free tool.
Is it
And
customizable, sir? Orange, is it customizable?
customizable means it has a bunch of different algorithms which you can pick. So you have to just run, it will take you through the entire life cycle, like how the Quiz VM, it will ask you that, tell me, give me the get me the data. Then you identify all the variables which are relevant. You define the variables, whether they are predictors or they are outcomes. Outcome variable, like in a classification, there will be one outcome variable, and then you can do a bunch of exploratory visualizations, histograms, and plots. And you can also select some models like k-means clustering if you want to do unsupervised learning, or you want to do neural net or any of these types of supervised learning. You can apply that. It will give you some results. So I'll try to show you if I get time. First, let me finish my Tableau question, because I think you might have a course on analytics, I believe, right? Predictive analytics or anything coming up in the coming terms. I'm not sure how your program is curriculum is set designed.
Machine learning.
You have a course on machine learning.
Yes.
So you will do this. I'm pretty sure that the faculty will take you through some of the tools, and I'll just anyways send you the link. Yeah, so maybe I'll just share my screen only. That is better.
Yeah.
Are you able to see this orange data mining screen of mine? I don't know. I'll
No,
just
right
sir,
now
no,
we
sir.
are seeing the case study. We
case
were.
study. Okay, let me just change the screen moment. So this is one tool which I would recommend you to start with, and it's free, and it is built on Python libraries only. So you can just simply start downloading it. It's an open source tool, and it's quite popular also now in academics at least. I don't know in industry how many people are using it, but you can.
Mostly, I heard about data integrator, sir. Actually,
Okay, that is the SAS tool you're talking of.
SAS tool, yeah, data integrator we have heard because in one of our projects we had some of our business analysts using this data integrator,
Okay,
wherein we were having some multiple country data.
okay.
Somehow they're using that. I don't know. I mean, how they
Well,
are using it.
SAS data integrator is more like a ETL tool. Okay, that will not give you the predictive modeling or the predictive
More of a
analysis.
backend. It will be a backend system for getting the
Correct.
data from the source database.
Yes. And
And
it has very less BI related, I mean, visualization related, reporting related feature. But
Right.
once you use that and build your data, then you can use VI,
Hmm.
Visual Inspector, to do the modeling and stuff.
And SAS, I believe, has a whole bunch of different tools. So this is the visualization and reporting tool, which is the BI tool we are talking about. Okay, let me first, you can go through some of these interesting plots, which can be done on very simply through click and drop on using what do you call Orange, right? So these are some of the examples which Orange has provided on its like you can do these box plots, can create heat maps over here. We'll do these things in definitely in Tableau, but as you can see, right, you can do like clusters, you can create hierarchical clusters. You can create these classification trees, what we were talking about. So this is how the model works. You load the file, you select from this bouquet of tools, which type of model you want to apply, and then you connect the two dots, and it will. This works very similar to SAS Enterprise Miner. That SAS has a similar thing. Then you create your outputs, which are either in the form of a tree diagram or scatter plots, and then you link them together, and then you get these nice nice visualization, which obviously you will then interpret it because you know the data and the data set and you understand the context well. Nah? So these are some of the examples. So they have talked about hierarchical clusters. So whatever you have studied in your statistics class is extremely relevant. You will never have to, because statistics is all your data science and all works very much, you know, on the same lines as what your statistical models are. So we kind of use both statistical techniques like clusters and all that, and your traditional data science techniques like your classification, regression trees, etc. And these are the performance parameters. Like this is something called as an ROC curve. They have applied two models here, logistic regression and ROC, random forest, sorry. And they create these kind of curves which sort of have their own definitions of how to interpret the performance. So you will study these things in your next class. So there's this called true positive rate. There's a false positive rate, that is specificity, sensitivity, and many other metrics are there to measure the accuracy. Just like how in that case study, we had a neural network model which had a 79 or an 80% accuracy. So these are very so on a simple sample data set, you can maybe try many different types of. So you can see that they have also tried to do some topic modeling, which is part of natural language processing, which is now more relevant given that we have unstructured data coming into which we want to analyze also. So it's a good tool, very friendly, easy friendly, and very simple. But the underlying methodology and uh, the model, that part is a little hard because that takes time to understand. It doesn't happen very easily because that is the base on which everything works. Now you need to understand how that model works, how that model does the analysis, because that is the base on which I mean, you can use the tool, but if you don't know what it does, then you can't really properly explain the results. So that's a quick marketing of this tool, which I don't have any interest in marketing as such, but it's, as I said, it's something to start off with. All right.
Yep.
And SAS, as I said, is a fantastic tool, but is a paid tool. So they don't have a very I mean, their softwares are expensive. So
It's
not
way too expensive, Professor.
Yeah,
way too expensive.
way too expensive. Even companies, big companies, can't pay for their license costs. It's so expensive. And they have, I don't know why they have tried to be like that, very niche. Because of them, because of that, all these Python and R and so many of the other free tools have started becoming more relevant because people know that this is a good tool, but it's so out of their reach. That's why.
See, their license, Professor, is just part of it. Okay. The problem is with the ATS.
Okay. What is that?
The ATS is the kind of suppose you buy the license, maybe you get the license for lifetime, but that really doesn't matter much because they will tie you up. Their licensing is such that you will have to pay for the ATS for next 5 years. And that ATS is huge. That's the problem. It's not a one-time.
That is a backend element.
No, ATS is like the after-sale support kind of thing for the software.
Okay, got it. It's like a subscription of their
subscription model. Yes. So I will pay. Suppose I'm buying the license, and they make agreements in such a way that you will be bound to do that. Their agreement will be like that. Okay, this license will be lifetime free only if you take the ATS for 5 years. So that kind of license. So you are going to pay them for the next 5 years or 6 years for sure. So big companies also fear for that reason. Yeah.
But the good thing is that it's a blend of both. That is like if you go to Python, then it's your core into the data science as a technical guy. The beauty of SAS is that it's kind of flavors of both. As a front end non-technical person, you have an interface through which you can give the commands and run the programs. Or if you are you are an expert programmer, you can straight away go to the programming interface and just write all your codes and create your scripts. So in a way, it caters to both the technical guys who are familiar with programming and can write code in a typical SQL format, as well as the ones who are the less technical people who are more comfortable with an interface kind of approach. So, yeah. So it has its strengths for sure, and big banks and big companies all have SaaS licenses for sure.
Right.
Okay, so let me get back to our PPT. So we were at this point where we were talking about, can you see the presentation?
Yeah, we can.
Okay, great. So we also went into this whole, just give me a second, just to get my screen. Where we also talked about the different elements about strategy implementation, because ultimately these dashboards are a means to measure performance of the company, of the product, of the service, of the division or department. So ultimately it is aligned with strategic management, and it's combined with the basic strategic goals, initiatives, models, or targets which are there. And these tools are a means to execute those strategies and monitor and measure and probably do course correction if these results are not aligned with what the goals were at the beginning of the year or quarter, whatever it might be. So these are ultimately, as I said, a whole comes into that whole umbrella. right? And that's why we have this concept of KPIs, key performance indicators. And I think I believe that today we'll also spend some time on your project, because you have a very good, very exhaustive project to do. So the project also has some KPIs which they're tracking, and then they're seeing some issues with the KPI, with the performance, and they want to analyze that problem analytically, which means that they are going to look at the data, look at the frameworks, and then prepare some summarized visualization, and then provide some insights in terms of what might be the reasons why these things happen. So every kind of a business industry context, business functional context will come into definition of what are the critical metrics which matter to that particular organization. And that's a pure business decision which will be taken, that these are the important KPIs we need to track. And for that, we need visualizations to give us the real-time updates on what is the performance at any given point of time, right? So this is the whole idea behind descriptive analytics, a presentation of the real-time data of whatever has been the current state of affairs in terms of the past data. And all this data, what we were discussing, all these numbers are getting refreshed and measured on a real-time basis. So as the things change, as the operations, depending upon the performance overall, over a period of time, these numbers will move up, down, and they will get updated. That is the whole idea behind creating these dashboards. Of course, now when we are studying in class for this course, we are just going to use a practice data set and get a feel of the application, which is what we want to do. But in an organizational context, we'll have you will be using a kind of a tool which will connect you with your backend system, where you will be able to run all these calculations, because all these are calculations, like how many leads were discovered, quantified, disqualified, and all these calculations are what your models and your scripts will run, and it will get refreshed on an ongoing basis, which is what the model has, this is what the real-time aspect of the visualization is about. And as I said,
quick question, Professor, may
sure,
I
please,
interrupt?
yes, please.
So probably, are you referring to the regular data processes or ETL processes, I would say, which will periodically, either 10 minutes batch or 2 hours batches, they will keep refreshing the data from different source systems, on top of which the Tableau will run for the dashboards?
Yes, absolutely. So we had also, I had just taken you through one of those stacks in terms of how the whole process would get carried out. So we are basically looking at that there are a bunch of tools, like you mentioned, right? The ETL tools, which are, just delete some of this.
So either Talent or Informatica, Ab initio, anything might work here.
Correct. So you have these whole set of extract, transform, load applications, which will create your backend systems, which will work as your data warehouse or data mart, depending upon how you want to design your backend systems, from where the Tableau or your visualization tools or whatever scripts, or even your whatever, if you're using simple like your XML and ASP or whatever script or language, they will do the job of presenting this data in this in output form, and that will be used by your business users. So this is also the part which we talk about, how the refreshment happens. So on one hand, you have your operational systems, which is really where all your data is getting generated, because the main point is that your data is getting created in these internal operational systems, be it your ERP or a point of sales or some other application. But from there, we are using, as you said, right, the bunch of different applications like Informatica or some tools to create and maintain and on a regular batch basis, or depending on how much refresh rates and refresh policies are there, connecting to all these data sources and then applying those rules and keeping it, syncing it with the respective warehouse or the subsets of the warehouse, which we call as data marts, which will then be picked up in those respective reports which are through the tools like Tableau, which are connected to these marts
Yeah,
or
data marts. Yeah,
yes,
right.
exactly. So this is the actual how it will work in a corporate environment. Of course, for our course, we just need to just understand these concepts, and when there is an implementation project, then obviously all this will play a role in terms of knowing how this whole thing takes place. But eventually, we are now trying to get a gist of how to present, how to get this based on some sample data, how do we create these dashboards using Tableau. But as I said, the journey doesn't end there. There is a whole bunch of descriptive, predictive and prescriptive models, which will also come from other tools like your Python or libraries, like or your Orange or some other tools, which your R or something like that, where you have created these statistical and analytical models, which will give you more deeper insights over and above what your dashboards can give you, like how we saw it in that example, in the case of the athletic injury. So this is how the whole journey of data management to data analytics goes in any organizational operational context. So let's so as I said, from a dashboard point of view, what is important to understand is what are those KPIs which are relevant to be tracked, and those KPIs need to be defined and how they are measured, how much how that whole thing has to be described. For example, now what is this term? Like, for example, now I have just picked this up from somewhere, but there will be some specific terminology of how you calculate the say average sales cycle. What is the formula for that? So there will be formulas for just about everything, and those formulas have to be included in the design of the dashboard. So there are ways to create these formulas even in Tableau. So in Tableau also you have a lot of options where you can not only design your visualization but also create. Sorry, did I stop sharing? No, I didn't stop sharing. Okay, fine. So in Tableau you have this whole set of things which you can do to ensure that your calculations can be done. So you have create new fields also. So there might be some existing fields which are coming from your backend systems, but you will create your own KPIs and fields, which could also be included as part of the application backend, or it could be done on the tool itself through some calculation. Just like how we use Excel formulas to calculate all the different calculations on Excel. Similarly, we can use that inside the Tableau or visualization environment as well. So just a quick idea why this tool, what is Gartner? Gartner is one of the top, market research agencies in the IT space. And so there they do these studies on different types of tools and products. So this is their analysis of the analytics and BI platforms where we are right now. So what is the basic idea? That all these tools which are BI platform, that's why we say the business intelligence and analytics, and I spent a bit of time explaining that business intelligence is also called today as descriptive analytics. So as to understand that there is data science and business analytics separate as another set of things which you can do, right? So the idea is that this is, as I said, the main focus is on visualization. So the idea is that you can, with very simple interface, connect to your data sources, identify all the variables, classify them into quantitative and qualitative variables, because we have seen that there are basically 4 types of variables depending on whether it is a nominal, ordinal, interval, or ratio scale data. And then be able to do this, what we call as dimensional modeling, which we discussed, right? The combination of fields from both the quantitative and qualitative. And it has to be done typically for business users. So it has to be in a kind of very easy interface with a very low code, no code kind of an environment, where there's no real technical stuff involved in writing it, like how you might have to do it. If you want to do it in Python, it's very hard to do the same things. It's going to be a lot of effort in trying to replicate what Tableau does in Python, because you need to write the code. It's a programming language, but it gives you all the flexibility of a programming language, where you can do whatever you want with it. Whereas here, you have a bouquet of different things. You go with that. mostly they are quite adequate. You won't need to do too much more, right? It already provides an exhaustive list of different charts and graphs. Uh, so these are in general for the market as a whole, which means that it's not just about Tableau, but Tableau, Power BI, Microsoft Power BI, and even ClickSense. There are three tools I'm familiar with, which are all very powerful tools for visualization. So this is one of the, this is what they call as their magic quadrant. So this is the magic quadrant I picked up, I think, the last year. So this is the 2022, and it won't change too much. These. So have you seen this kind of a graph before? Gartner have anyone?
Yes. So for all the different products, when say we are giving a proposal to client, right, for a tech stack for a particular project, we also
Right.
tell them why we have chosen that particular product, right? So we show them the data, and normally Gartner chat is one among them to showcase the client why we have chosen this product. For example, Salesforce, we are choosing for one of our projects. We'll tell them, look at this. Salesforce is in the leaders quadrant, in the magic quadrant,
Right.
kind of, yeah.
So just to for the others also, for the benefit of the other students, so they have this 2x2 matrix which they use to classify all the different products in a certain segment. So like that, they have different segments. Like this is the magic quadrant for the analytics and business intelligence platforms. But like that, they have, say, for ERP and for enterprise applications, they will have a different set of products. So what they have done is they have created this 2x2 matrix where on one side they have on the x-axis something called how broad in terms of the depth and width of the application is, in terms of the scope of the things that you can do with that application, and whether it can be applied, whether it has a good, set of features and functions which allow it to be used in various different type of scenarios. So this is what they call as the completeness of vision in terms of how small, narrow, or large it is. And somewhat related to that is about the execution capability. That is, can it be used on for different industries, for different types of businesses? How scalable that app is in terms of its ability to be applicable in different scenarios. So if you see here, broadly, the companies which are niche companies, which are what they call it niche players, will have a specific set of applications which are relevant for a particular type of users only. So a MicroStrategy might be only relevant to a business intelligence users, but doesn't have a whole set of maybe other features and functions. So these niche players are specific to a particular set of features which are relevant for a particular industry or a particular geography or a particular type of business model for whom that product and tool works. And then as you move from here and to go into this direction, the product is now a general purpose. Many different type of companies and different type of businesses, small and large, can use it. So you see that these three are the top products, and how they do the exact X, Y, and how they put it into which one higher, lower, that we can skip for now. But it gives us some idea that, okay, these are the 3 or 4 main people, the players in the market who are, whom you can, use any of them and you will get really good results. Then it's a matter of comfort level and, the sales approach in terms of which ones you feel is more comfortable. But some people use Microsoft and or Salesforce, Tableau, and Click. So ClickSense, Tableau, and Microsoft, all three have been in the top 3 positions as far as business analytics and visualization tools are concerned. But there are, as I said, the SaaS and the SAP, some tools and stuff like that also. So this is a very good analysis, and they keep revising it on an annual basis. So you get a refreshed view, and they'll explain why they have put this into a leader or a challenger or things like that, and what have been added. For example, Tableau was acquired by Salesforce about, I think, 2 years back, I think, and then now it's become even more, I guess, better, because now the whatever Salesforce CRM, whatever platform they had, is now also sort of connected with their visualization tool. So it become more powerful in that sense. Some of the basic features which has made Tableau very successful overall is that it has their own whatever intuitive patented visualization, their SQL engine, which is basically the engine which is running in the background, which you don't know, but which is running in the background. Whenever you do this click and drop, it is doing that automatically. And over a bit of time, they also have a very big set of community of people who are their customers, partners. In fact, even for educators also, they have a very big Tableau for teaching program, which you can sign up for as an educator. I think you have got some educator licenses. Yesterday, somebody was mentioning that, there is some licenses you all have also got now from the NMIMS thing regarding the paid version.
Actually, yesterday I signed up for the student license, and I got it within 20 minutes from Tableau itself.
Okay, directly without
Yeah,
having.
yeah.
Okay.
Yeah, we just need to submit our IDs and some results of the last SIMs. Then we'll get it.
Understood. Okay.
And how many days it is, or how many months it is valid for?
Usually 1 year.
1 year. 1 year.
1 year. Because this Tableau for teaching also, I keep getting emails from them that, do you have any course where you want to also get licenses? You give us the description of the course and the number of students. We will give you like a lab based courses. Now these come under, so they can be taught in the lab, the computer lab basically. So you can say that, okay, I am teaching a course on Tableau and I have 60 students in my class, so I need 60 licenses. They'll give you. Even to the faculty, they'll give you. You have to give the details about the course and in which semester you're teaching it and which institute you're affiliated with and all that. So they are doing a lot of, in that sense, soft marketing of their thing. In fact, this whole Tableau public is a very nice way of allowing people to use it without having to worry about license keys also. No? Because in Tableau public, you don't need a license key at all. You can just simply use it and share your visualizations.
Yeah, but you don't get to keep your own visualization confined to you or your own data stores.
Correct. Because it is a cloud software. It uploads everything on there to the Tableau public server.
Yeah.
So that is the limitation. So any proprietary data, if you have, then you can't use the public version. If you are using some extra data which you have collected from some open data sources, databases or Kaggle or something like that, then it's fine for practice, training, learning purpose. But internal applications and internal data from organizations cannot go on public, obviously. And this Salesforce ecosystem, now it has become a part of it. So it's now having its own set of integration with the CRM package. Metrics, I said, KPIs, again, very important to know how to select your metrics, because there may be so many things which you can actually quantify. Anything which can quantify can become a potential metric, but you don't want to try tracking everything. You want to track a few things, but they are directly connected with your strategic plan and your performance metrics. So there's a nice video, you can maybe watch it, about how one person talks about how companies sometimes make mistakes in tracking the wrong things, and they kind of sort of lose maybe the bigger picture, which is probably what they are supposed to look at, because they're trying to look at the wrong things, or they're trying to track the things which are not giving them the right insights. So he's given a very good example of what are some of the good and bad metrics which can be done within the same in the same organizational context, and what will be the advantages of choosing the right metrics, and what are the disadvantages of tracking something which is not relevant or not giving you the right insight. It's like you are being treated for a wrong you're taking a medicine for a thing which is not relevant for your disease or problem, that kind of thing. So there are also some kind of advice on how to try to ensure that you track the right things, you measure what is relevant, not because it's convenient or not, or because you have the data with you or not, but because it is, as I said, connected with your strategic perspective very clearly. So first, that strategic goals and strategic management ideas have to fall into place, then the tracking and measurement will make meaning, because your plans will become, if your plans are well defined, then your metrics will become that much more powerful in helping you to achieve your plans. So, and also another thing is that just only focusing on the quantitative terms, which are purely financial, may not be a good idea. And that's why a lot of people have used the balanced scorecard, where they are tracking in their KPIs, not just their financial parameters like their whatever revenues and sales and margins and etc., but they're also having some metrics which can be used for tracking how their customer behave, like customer satisfaction scores or customer quantitative, something which they can quantify from a customer perspective, which is data which is generated from customer data, which is basically like customer feedbacks. Something on the process side also, in terms of how efficient or how good their productivity is in terms of processes. So there could be some KPIs which are specific on operational aspects in terms of time or cost or effort or something which is helping them to evaluate their productivity. And also something on the learning and innovation part, which is how well they have been able to create new business lines or product segments or innovate on the and experiment with something new. So not all of it will be quantifiable. There may be some things, like in the case of these innovation parameters or internal parameters, which may be soft measures. They may not be very well defined as a quantitative measure, but they are still important because that gives a much bigger proper view of how this works. So this is quite a popular now model, or you can say scorecard, which is used to track both financial, non-financial parameters. There are metrics which are both lagging and leading, just telling you about what happened in the past versus giving you some future aspects also. Both internal and external also, it has some of these internal elements like their processes and innovation, but the customer and financial is more from an external point of view. And some qualitative variables also are relevant in any kind of exam analysis. So not only the ones which can be exactly quantified, but also which can be qualitative in nature, but they are still relevant and important. And both covering short-term and long-term kind of a scenario picture, so that you get a full balanced view of the organization by looking at all these things. So if you look at things like even attrition rates and any other kind of measure or metric, can you think of some measures or metrics which you think might be very relevant where you are currently, working on? Which, if you have a system or a dashboard to track, then it will make it easier for you on an ongoing basis for the management to be able to evaluate how we all are performing.
Yeah, kind of percentage of workforce female, how many percentage of female workforce getting promoted or in leadership position, something like that. And then attrition is something you mentioned. Yes, that is something being tracked also. Those kind of metrics.
Yeah, attrition, shrinkage. Then for a quality parameter, we have a NPS, like Net Promoter Score. When we do the survey of the customers, they give the feedback, like upgrade does, for their learning.
On a scale of 1 to 10, like how you will be.
Correct. Yeah.
How will you? What is your experience from very good to very poor? That kind of thing. So yeah, a lot of this came from the marketing lead and all that loyalty metrics and satisfaction scores and all that. So a lot of it has come from sales and marketing, and I'm sure there will be, even in operations, something interesting which can be tracked for measuring the productivity of the people and resources and something on those lines. Like, for example, if you look at customer support, then what are the wait times or what is the cycle time, like how we typically see in
TAT,
operations.
turnaround time.
So turnaround time, exactly. So those kind of metrics can be very relevant to understand the duration and product, if how good or bad that process perform is as a whole, and how we can improve those processes. And so many things have come up in operations on Six Sigma and on quality management to improve processes, internal processes actually. So this is one interesting dashboard which was developed in one company called AMC. We'll discuss this in the next class because I thought we'll start with the dashboard. But this is one more case I want to discuss because it gives you a good feel of the dashboards and how these dashboards are being used. It's in the context of a media company, and they are basically trying to look at how their company is performing vis-a-vis their competitors. So this is there in your textbook called AMC Networks. Let me just open up the book. I think you have got access to all the resources. So I'll just open it up and we will discuss it the last class, which is next Saturday. I'll just show it to you so that then you can open it in the week whenever you get time, and you can do this, read through this, and we'll discuss it in class. So just give me a minute. I'm opening the textbook. So I don't think that I think Upgrade has recommended any book as such, but I think in general, when we are teaching in these schools, as a part of the course outline, we have to recommend a textbook. So we are just used to this whole idea that there must be a textbook. And of course, textbooks are good because they give you a very good conceptual understanding of things. And then obviously you can explore further as you use things. So this is a book which I have already downloaded and kept it for your reference. And it's a fantastic book called Business Intelligence, Analytics, and Data Science. So it's kind of covering all these three things, and it has a very management perspective. Book typically recommended in all business analytics courses which are taught in MBA schools, and they are all foreign authors. They're all mostly US, I believe, Ramesh. And so the AMC case, I have taken it from one of these. So they have given very good explanation of all these whatever we are kind of trying to cover in this course, in terms of how, and even this athletics case study is also from this book only. I have picked it up from one of the chapters. And they have a lot of good examples and case studies from, but they're all US context case studies. So where is the search button? So the AMC Networks is also there here only, one of the chapters.
Professor, do we have access to this particular book, or we have to?
I have already shared. I have shared one OneDrive link.
Okay. Yes. Okay, got it. Yes.
That OneDrive link has got this book, and if you want, you can also download it from the LibGen. You all are familiar with LibGen?
No, Professor. Sorry.
Okay. So I will show you one site which is very important. Site is called LibGen. It's by the same people who have created SkyHub. So libgen.is. I'm just trying to lib. So it's it may not exactly be the most authentic way of downloading books, but that way you can just search for any book based on title, author, publisher, ISBN number, and you can just simply download it from LibGen. So
and there is no issue of copyright and anything.
So that all I will leave it to you to decide whether you feel.
Okay, got it.
So that is, मैं अपने मुंह से कुछ नहीं बोलूँगा. आपको जो करना है आप करिए. That's your idea.
Sure, Professor.
But this is a valuable resource. So for all the people who can't, I mean, you can always buy this book also on Amazon. If you search this book on Amazon, I'm sure you'll find this book online also. There is an Indian edition of this book, so you can buy it from Amazon. You can just type for Ramesh Sharda Analytics, and I think you will get something will come up. He has written many books on analytics. Yeah, so this is the same book, I think. which is the Indian edition. So you also have the choice of paying 660 and getting a official copy, but it will not be in ebook format. You'll get the book in your as a print,
Paperback.
as a paperback. Yeah, but you can buy also if you want.
Yes, Professor, please tell us that website again. The website you were
Yeah, so it
just
is called libgen.is.
Libgen. Yes, okay.
Let's put it in the chat window also. So this is for all books, even your conference, public proceedings and all. If you
Okay.
want to search for, because a lot of these conferences which happen all across the academic circuit, they come with a proceedings, which is like the compilation of the papers in that conference also. So we also get these conference publications also. On my LinkedIn, there's a guy called, I think, so there are a couple of people on LinkedIn also who are really very good, who will give you a really good insight on this whole area of data science and all that. So if you connect with me on LinkedIn, I will direct you to some very good resources on LinkedIn of people who are very, very good in explaining everything on and the latest state of the art, whatever is happening. One person who's more into econometric modeling is called one guy called Tanujit guy. I'll forgetting his full name. I think it's Tanujit Bhattacharya. He's affiliated to a couple of business schools also. I mean, some of the IITs also. He's very well. He writes very well and he explains many things. Status. So I have some references. I think it'll be best if we connect on LinkedIn now. Then I can redirect you to some of these experts who are there in this space. So okay. So these are also some more resources, but for the next class, I would suggest you read this case, which is on the page number. This page number now. Where are we? Which page? This is it's on 5.2. Yeah, page number 283 of the ebook. So you can refer to this, right? So this is one case we will discuss next class. Basically, it is a implementation of a dashboard and the organizational context of why they use the dashboard and what were the kind of insight you were able to generate from that, right? So we'll discuss this in the next class. So that will be like your homework for this week. Besides, obviously, the fact that you have to do your project properly. No? So should we take a 10 minutes break? I'll just set up my Tableau public also. And in the meanwhile, what I would suggest, what time we started? 9:30, no? 10:30, right? We started 10:30.
10:30.
10:30, no? So you will have to install the Tableau public or Tableau desktop or whatever Tableau license version you have. We can use any of them. The important thing is the data set also. You can start with this sample superstore data set. Do you have this data set with you, or should I just share it on the chat window also?
Professor, is it there on the shared drive?
It should be there. It will be, yeah, it should be there. It is definitely on my shared drive. And just for the class, I'm also just uploading it on the chat window also. So just save this on your screen, and we'll start with the Tableau interface. Okay, Sachin, 1 second. I think there is Sachin is facing some problem. 1 second. So where is Sachin? Just give me a minute. One. Hello. Okay. Okay, I think now everybody's there. Okay, so I think you have the data set with you. You have installed Tableau Public or Tableau Desktop, or if you haven't, then do it. I have also put the latest Tableau Public on the link also, what I shared. You have the link with you, right?
We'll check, Professor. I think it
Okay.
was sent.
It was sent. I'll do one thing. I'll just search it on my mail also, and I'll just put it into the chat box, and we can then start in about 10 minutes time. Is that fine?
So we will install Tableau. Then we'll start it. There.
Yeah. You can install
Okay,
Tableau.
okay.
So we'll take 15 minutes maybe. You can just search for your Tableau desktop, or you can go online, and like I showed it yesterday, you can just simply get it from the desk. You can get a you can just search for Tableau desktop, and you should be able to access Tableau desktop also. I'll just
Okay.
open up the screen also for you for your reference. So if you just simply type Tableau public, it'll take you to the website Tableau public.tableau.com, and you'll have to sign up here. Once they'll ask you to either sign in or sign up. So if you already have created an account, then you can just simply sign in, or you sign up and then you download the latest version. I have also shared that in that link also, so you can access it from there. That's a 64-bit for a 64-bit Microsoft Windows setup. But otherwise, you can even from here simply go and download the public edition version, whatever latest version they come up with. Okay.
Okay, Professor. Thanks.
We'll see you in about 15 minutes. So 11:55, we can regroup.
Okay.
See you.
Tableau. आप सोनाक्षी नहीं जा रहे हो?
All right. So let's start now.
Hi, sir. Yeah.
Yeah. So just one question. I think Shubhankar, sorry, for Sachin, now that this you dropped. Just mention where you sent a mail on which a Tableau support or whatever that email ID now on which you asked for the license. Because I have seen this Tableau for teaching. They have something, but I think it might be for that also. Let me just check. Yeah, so there might be Tableau for students, Tableau for teachers. Just explore and see. We offer 1 year Tableau license to students at accredited. Okay, sorry. I'll just unmute whoever is not unmuted. 1 second. Set. Stop the sharing. Yeah, I think now everybody has that unmute access, no? Yeah.
Sir, actually, just want to elaborate on the steps.
Yeah. Where did you send the mail and like?
Yeah, we have to go to the Tableau for student.
Acha. Okay.
Tableau for student, and then there will be one form will come up, and then we have to select the NMMIS the drop down.
Mhm.
Yeah, but there it is asking for a email ID given by the school. It is saying, okay.
No. You can pick place your email ID that is registered with NMMIS.
This
Okay,
I
so that should work. Okay.
are you
Yeah, this is the form. Yes, this is the form I'm talking
for
about.
me?
Yeah.
There is a separate form. This is for the students, I think. So only thing is, if how will they verify that you are affiliated to the school? Is there
We have to upload the documents as well. Like you can
Acha.
submit our ID and last
Email ID,
semester.
not email ID, sorry,
result.
your roll number, your roll ID, that ID card. You have an ID card,
Yes.
but you
ID card.
you have an
ID.
NMIMS video account created for you, no, that you don't have. Right?
In the email section, we can put up our Gmail ID. Normally registered with that.
Okay. Yeah, in general, I think all these people they are very comfortable if they see a .edu ID rather than a Gmail ID. They are very comfortable if they see a .edu, then it happens very fast. It happens like almost immediately. But otherwise, you can even, I think, I'm sure they might be having an option that you can put your fee receipt or your admission letter or whatever.
Yeah, I have put my NMMS ID given to me and last 3 semester result.
Okay, great. I'll also have to do this because now I'm teaching at Tableau in IMI Delhi. So for the entire that section C, there are 60 students are there. So I'll have to go for this bulk license for the entire course. So I think there is some option where I can just straight away go for a bulk license of maybe. So they can. So they are saying that you get one. You'll get one ID, like one product key code, and you can run multiple installations with that one ID. So I think one of
distribute to the students.
yeah, so all the students will get it. Actually, I should have done this with you all also, but maybe next batch I'll try to do it in advance. Because I'm not a full-time I'm not like teaching you all very I don't know the setup of NMIMS properly, like in terms of the back end, whatever happens. So that way is this is more for like typical classroom teaching, which is done in a contact where there's a contact center and that kind of setup. So there it becomes more easy to because everybody has an email ID. All the students have a
and also Ankita has offered the license to Harsha Gupta, I believe.
Okay.
So maybe other student can connect with Ankita as well.
Ankita
they don't want to do this.
Who is Ankita?
Parmar,
Pujari.
Ankita Parmar, right?
Ankita Pujari. Upgrade guy, upgrade buddy.
Upgrade person. Okay. I'm not familiar. But as you
Okay.
said that, these companies have done a lot to promote their tool in academic institutions so that, people can try it out. And all of them have all of the access is 1 year standard access.
So you mentioned Ankita Pujari or Anjali Pujari?
I
See, it
believe
is
it is
Anjali Pujari.
Ankit.
It is
Yeah,
Anjali.
Anjali Pujari, I think.
Okay, cool.
Okay. And there are many different versions of Tableau, actually. So this is the traditional, I think, the basic, the main flagship, whatever the desktop application, I guess. Okay, so now that you have got this setup ready, we can then now start exploring the data set and load the data in Tableau environment. 1 minute, I'll just close all the extra windows. So we'll discuss this in the next class, okay, the last class. And I think some feedback has also come. So those of please complete this feedback, whatever has been shared in the break.
It's done, sir. Yeah, that it's done.
Sure, thank you. 1 second, let me just open Tableau now. So let's just explore the data once in Excel only. It will be easy to just see that. Let me just share that specific screen also. So the okay, so now you can see, right? This is the data set what we have in Excel. Can you see the Excel sheet?
Yes.
Okay,
Yes,
so
sir.
if you see, these are all the different, this is one sample superstore data. I think it comes with one of the free tools, and we'll try to do some analysis. So just to recap, right? We had discussed this concept of dimensional modeling in the previous class. So the idea is that in any kind of when we are doing these kind of analytical query, basically, we are trying to create different charts and graphs by combining these dimensions and measures. So this is the basic concept of dimensional modeling. And because there is going to be a bunch of qualitative and quantitative data, right, in any data set. So if you see in our data set here, there is all these fields what are there, which are like, for example, order ID, the shipping mode. We can just because I think all of us are more familiar with Excel, because Excel is like the basic tool all of us have. So you can just apply a filter just to see, like, for example, what are the different shipping modes. So there is first class, same day, second class, standard class. So these are all like what we call as typical nominal variables, because these are all your dimensions. So the main difference between dimensions and measures is dimensions are all the qualitative data, which is typically non-quantitative, which means they are typically either nominal or ordinal scale data. Dates and quantitative field, like for example, here there is a sales quantity, sales amount. So this is a quantitative field. Quantity is a quantitative field. Is your quantitative field. Discount, profit. So these are my measures. In a traditional data warehousing context, we call them as fact and dimensions. So if you see in this diagram now, we have this idea that all your quantitative data, we call them as fact in the traditional ETW context. In Tableau, we call them as measures and dimensions, which is a very good way of explaining the same thing, that there are dimensions which are qualitative fields, and there are measures which are quantitative fields. Like in this case, sales amount, sales order quantity. In our case, it is profit, discount, quantity, and sales. Now, date is a slightly interesting field because it's neither proper quantitative nor qualitative. I mean, it has a little bit of, it is more tending towards quantitative, but it's not really as useful as a pure quantitative field like number. But it gives you a sort of an ability. So we'll see how dates are actually represented in Tableau, because it gives you very different type of analysis, depending upon whether you want to use it in a cross-sectional context, which is like a snapshot, or you want to do it in longitudinal, like a time series kind of context.
So based on the requirement, we can use it either as a qualitative or as a quantitative.
Yes, so the idea is that we will show you the different type of charts where we can tell you how to interpret this date variable, because you can different type of date-based analysis. So I'll explain to you when I show you in the Tableau environment, but it's you can say somewhere in between, neither pure quantitative nor qualitative.
Right.
The other fields are purely qualitative fields, which are where you have a country or a city or a state, region, product ID, categories. So these are all the different categories. So in this data set, there are 3 types of products which are purchased: furniture, office supplies, and technology. And then if you filter and say, for example, furniture, then there are some different types of subcategories within furniture. Like there is a bookcases, chairs, tables, etc. And like that, if you change the product for category, which is the group, there the different products within that category change. For example, in office supplies, these are all the different office supply products, and each of them have this unique product ID. So we have a simple data set here. There's not too many other, there are some tables outside also, which are one returns is there, but we really don't need to do that much of analysis for this. We have enough of variables and fields which we can analyze here, and from there come up with whatever insights we would like to explore in terms of which sales are happening in which part of which cities or in which regions, for what category of products, for which subcategories, whether it's sales, quantity, or profit, or discounts, or any of these things. And we can also see some time series, time that from this period to this period, how did the sales move, so on and so forth. Okay, so this is a gist of this particular data set, just to kind of give you some feel. So I always like to just manually explore some of the data in Excel, because Excel is pretty much like we all are kind of very good with Excel. But then of course now we'll bring it into the Tableau environment. So it's quite straightforward. Just go to can you see the Tableau public thing, this application?
Yeah.
Okay. So you can see that I have the public version, so I don't have many options of these connectors. They just have these basic connectors. But if you go to the paid version, or I'm sure if you're using the desktop version, you will see a lot more, all your databases and Oracle and MySQL and SQL Server, Microsoft SQL.
And in license version, you have
yes. Yeah, there'll be more than 40-50 different type of connectors, because that's the whole idea, that we can connect to any database, right? So let me just bring this data into Tableau environment, and then Tableau has a very good interface to verify all the data which comes. So I'm bringing the data. So it's now fetching the data from the Excel sheet, and it is doing all of that on its own. You don't have to write any code or anything as such. So this is my data set. So if you see now, it has created a new window called data source, and it is given a name, the sample superstore, which is the name of this site, sample superstore. Now you can see that each of these sheets, right? There are 3 sheets out here. There is an order sheet, people sheet, and return sheet. It has put it on the left-hand side as sheets names. And then now we can, if you need to join the tables, because if you have some data which is spread out in different sheets, so each sheet represents like one table, and each table has its own set of columns and rows, then you can join them and create those unions and things like that. But for now, we can just simply go with this main sheet of ours, which is the order sheet. We don't have a full database right there with us, so we are not really very keen on doing that, but you can explore those things and see. It's quite simple to assign. Basically, the idea is that you need to know which is your primary key and foreign key and need to map them and look at all those sheets together, right? So for now, we will just simply just drag this orders and put it into the table here, the drag tables here, just drop it inside. So it will start now loading that thing. Okay, I think you can see it, right? The background. So what it has done is it has now brought this orders sheet into your space, your whatever database space, analytics space, or there, whatever. So they have also said, given a summary and said there are 21 fields where each field is representing one column, right? So this from here to here, we have total 21 different such columns, right? From column number A to column number U, we have 21 columns, and these are shown here. And it is also given a summary that there are total 9,994 records. So you can also just manually just go down and see. You'll be able to notice that there are about close to 10,000 records here. Now, before we can start doing the analysis, let's verify if it has identified the data types properly or not. So if you see here on top, okay, this is the panel which will give you a summary of how it has interpreted that particular field. As I said, broadly, there are two types of variables. This is, which are your dimensions and measures. So all your blue fields are typically dimensions, and your green fields are measures, which are your quantitative fields. So all your quantitative fields, these are the four it has identified, and it has put this hash symbol to say that it's a quantitative field. And all your qualitative data, which is your nominal data, it is basically interpreted as a text field. You can actually just click on this thing on the top panel, not the whole row, but just the this part, just to understand what are the different types of field which are there. So, for example, if you click on that link now, it will whichever link you want, you can just click on it. It will open all the data types. So the data types are, these are the main, or any database will have either these are the maximum number of data types. Now, so the qualitative data is typically considered in data type for language as strings, right? So strings, so you can see the south, west, all these are strings. So it has done automatically this job of picking up the data type. For example, now when I put a pin code here, let's go to this field. So there is a postal code. Now you can see this map symbol. It has detected it that it is a pin code. And how it has detected it is that it has put it into a geographic field. So this is also one of the capabilities that they built in whatever SQL engine. It knows that this is not a normal number. It's not like a traditional, like a number per se. It has a very relevant connotation because it refers to a zip code or a pin code basically. So though it treats it like a number, it's a special type of a number, you can say, because it has a geographic code. And you can see that various types of geographical features can be captured, like a city name, a county in the US, a state in Indian context, in zip code, country, airports, area codes. These are some US data points which you can pick up, and then latitude, longitude you can obviously pick up. So these are all the automations which have been provided in Tableau to automatically detect the right type of data, because there are different visualizations. So there are some geographic visualizations which will be very relevant for this geographic data. So present some of your analysis on a map, on a map of India or a map of whichever country. Like this is US data, so it will be on a US map. So this is one other type of, you can say, field, but obviously you can always change. So this is not like hard and fast. You can always just, if you feel that something has not been detected properly, you can manually go and check it. So that's why we first do this check that we make sure that, for example, now if you see country, even country is shown as a globe, but country is mapped as a string because it's a qualitative field. So it knows that even though it is a geographic field, it has a country detected. This is a text, and this is a number, and that's why this tick mark is on number whole, and this tick mark is on string. Similarly, you will see that even in your numbers, like say for example, this is a quantity field, so there is a you have a number whole, whereas here it will go on number decimal. So by and large, it does a very good job of auto detecting the specific data types which are attached to this kind of a text or string, or whether it's a whole number or a decimal number. But you still need to once cross verify that it has, according to you, everything is looking okay or not. Now, this is another very important field. For example, this is called order. You can see these two fields are there, right? Order date, shipping date. Now, this has a different symbol, which is a calendar symbol, because it knows that this is a date. And here you will notice that there are two types of date objects. One is a simple date, which has just a date field in it. And there is a date and time, because if sometimes in some field you will see date followed by the hour, minute, seconds, HH, MM, SS, that kind of field, which will be in the same unit, but it will detect it automatically that this is a date and time field. So if you want to do any analysis, which is hourly analysis, then if you have that date time field, then you must show it as a date time field and not as a date field, because then you won't get that analysis which is at a hour, minute, second level, which you will get if you select the right data type. So as I said, it does a pretty decent job of getting the data types right. But as I said, 1 out of 10 times it might get something wrong, because it is a software at the end of the day. It might not automatically detect everything properly. Okay, so this is just a preview which we are doing, and now we go into the sheets. So if you see that ways, the design is very much like a Excel workbook, like how we have Excel workbooks now, where we have Excel sheets one after the other. This is the visual version of an Excel sheet, where instead of showing you the just the sheet, you have the different columns on your left. So you can see that these are all the different columns which are there in your data set itself, right? So on the left-hand side, you say that we have a column called category, then city, country, customer ID, customer name. So now these are what we call in the typical warehousing terminology as dimensions and measures. And we are going to now start exploring these different dimensions and measures and trying to see what is the data, specifically our quantitative data. Like we are interested in looking at sales across products, sales across regions, sales across categories, subcategories, etc. And you have all these things on the left to tell you that these are the data types which you have seen, and it has done a nice breakup and put all the qualitative fields on top and put all your quantitative data on the bottom. And the color coding is also that way done. All your blue fields are typically your qualitative fields, which are describing the dimensions, and these are all your quantitative fields on which you can run your aggregations, your sum, average, count, etc. Whatever we do. Are you familiar with pivot tables in Excel?
Yes, sir. Yeah.
Okay, great. So those of you who have used pivot tables, you will know, right? That it is so easy to. So actually, if you take the interface of a pivot table, it is sort of similar to your field view, what you're seeing now on this. For example, now these are my different fields which are there. And this is my Excel, you can say, window where the analysis comes. So this similar thing there. The UI is slightly different, obviously, because this is only a visualization tool, whereas Excel is a mix of so many things, including visualization. But the basic logic is same. That suppose now I want to look at the sales. I use the sales and I want to see the sales across my regions. I can do this and run my formula and say I want to use the sum formula. So it will give me a summary of sales, sum of regions. Okay, sorry.
Yeah,
Sorry.
vice versa, sir. Do it
Sorry.
vice.
Huh?
We have to do it vice versa. We have
Vice.
to
Sorry.
yeah.
Sorry, I mixed it up. So you have to look at the sales across the regions. Yeah. So this is my sum of sales and this is my region. So this is telling you the breakup. And this is telling you in an Excel format, in a tabular structure. Now the same thing we are going to do. Like say for example, I will take sales and drag it around, say rows, and I'll take my regions and I'll drag it on my columns. So now the beauty is that instead of seeing this kind of a visualization, which is you're getting to see the visual version of this. And on the right hand side panel, you can see, right, it has picked up the this suitable visualization for this kind of data set, data presentation. So you can see that it has already applied this sum of sales formula, and it has given you this 4 regions. And on the panel, you can see that whichever, like say for example, now this is called a horizontal bar, but it's the same. It can also be converted. Sorry, this is a vertical bar chart, but you can also convert it to a horizontal format. But it's this, whatever, since it's showing in the highlighted window on the right, it means this is the chart which is being automated or enabled on the screen. And you can see on the right hand down panel, it shows that for horizontal bars, you can try 0 or more dimensions and 1 or more measures. So we have done that. We've taken one measure, which is sales, and which is the green symbol, and we are taking one dimension, which is regions. And we have got a beautiful chart ready. Now, if you want to make a little bit more enhancements to this chart, you can slightly expand the width of this chart by making it fit width. So it'll kind of fit this whole thing. And you can click this show me tab to hide or show the tab. Now, one thing you can notice here is that I don't have these figures, values mentioned on the chart anywhere. Like I want to know these numbers, no? Because here I have these y-axis numbers, but I would like to see that number also. So what I'll do is I'll again take sales, but instead of dragging it over here, which is already there, I'll put it into what we call as the labels tab. So I'll just take sales and put it into label. The sum of sales operation automatically is done. So now I don't have to do it. I can just see the thing, and you can, if you are still not sure if it has done a proper job, you have Excel as your reference point. So this is my Excel data, right? So it tell you these numbers. So there is some very high level of precision happening here, I guess. So I'll just make it into a simple number. So 501,239, that's this number which you see here, 509,239, which got rounded off to 240. Yeah, so these are all like not rounded off. If you round it off, you'll get the same values. Now, a little bit more is that always whenever you present your data, it's always good to present it in ascending or descending order, because then you can get to see the highest and lowest in that particular space. So rather than manually seeing it, you can just use this option called ascending, descending option. So on top, can you see this arrow once? So you see the arrows now on top. So this is the ascending and this is descending. So you can just click this link. It will go in ascending order. So south is followed by sales, followed by east. South followed by central, then east, and then west. And reverse chronology. That is from top to bottom. That is maximum to minimum. Okay, so you have these two small ascend descend options which can help you to arrange the data in ascending or descending manner. And I would always recommend that whenever you show any chart, unless it's not required, put it into a top 10, top 5 kind of approach, so that you can see quickly. Now in this, there are only 4 regions, so it's not very difficult to see it. But if there were more, then it becomes harder to compare and see which one is the maximum and lowest. So that becomes much more intuitive when you arrange it in either ascending or descending order. You can also assign a title. So if you see here, there is a title, default title which comes here, which is whatever the sheet name. So if I change the sheet name, and make it sales across regions, like how we do it in Excel workbook. You'll see that the same thing comes here also. You can double click on this, and you can see the sheet name is like a object which is a pick sum, and this object you can also make it a little bit more fancy or highlight it by making it bold or adding some color and apply those so that it becomes more clearly visible. And all of this will then eventually go on your dashboard. So then you'll see you need to know what that particular chart is about. So this is the first simplest, or you can say the one set of analysis. As I said, we do the presentation, but then we want to interpret the data and we want to compare how these different regions are performing and things like that. Okay. So far so good. Any questions? Any doubts? How did you find it easy to do this?
Yes.
Trying to find, I mean, yes, sir.
Okay. Yeah, tell me if you want me to go slow. I'll be more than happy to go slow.
No, sir, this is really perfect way of going. I mean, rather slow or
Okay.
fast.
Okay.
Sir.
Sure. So what we have done in this chart, we will, as I said, the whole idea is to explore the data. We are in the exploration mode. We want to explore all the fields. Now, you can imagine that we had so much of data in our database, right? We have now like lots of data sitting here, like 10,000 records. But in one graph and chart, we have been able to at least establish that there is the western region which is contributing the most to this particular, in terms of this particular data set, and south is definitely doing very low. So now somebody may want to examine this a little bit further and see what is the reason why south is doing so poorly, and which are the product categories which south is doing. In that you can start analyzing that. This is how we slowly go ahead. Now, one small change is that the data, as I said, when we showed it in the window here, we said that this data could be horizontal or vertical. So this by default chart is called horizontal and is recommended, but actually we have created a vertical chart because our column is region. So these are our columns. Whatever you put in your column, they will come in column form, and X. So in a way you can say that your this is your X axis, this is your Y axis. That is one other way of saying it. Now, if you reverse it, I want to put the other way around. What I'll do is I can just simply drag it, move this up and drag this down. Now, my columns are this sales number. So this is a column, this is a column, this is a column. So your X axis now has become sales, and your Y axis, which is your rows, is now become region. So your Y axis now you have put your 4 regions. So now this is more of a, so you can also, now in this case, we will have to fit it into the height so that we get all the things spread out. And there's also a full screen entire view also, full screen mode also, which you can use to go into like a presentation mode. Now, which one looks better? This one or the previous one? Is this more intuitive or that more intuitive?
This also looks better, sir, I believe.
Okay.
Just need to sort out from highest to lowest.
Yeah, we can sort this also. We can sort this also ascending or descending.
And then bolding we need to bold data points.
Sorry?
We need to format it, bold, make it bold.
Make what bold? The X and Y axis.
Yes, yeah.
Okay, that's fine. But I'm saying in terms of the presentation, there's also.
As per my understanding, this looks better, sir.
This looks better. Okay, what I
can have other ways.
As I said, it's all a design aspect. There is also one button here called swap. So you can just simply swap and see the X will become Y, Y will become X, and you see which one looks better, more intuitive to you. Now, some people like this chart because it's more, they find this more intuitive, that the y-axis is the quantitative field, and on the x you have the 4 bars or columns for the 4 regions. But as I said, it's a design principle or design. Whatever looks more intuitive, whatever intuitively captures the message, that ultimately we have to communicate which is the region selling the most and selling the least. So some people will find this more intuitive because it can see the thing easily. But as I said, it's a design choice.
Sir, I just want to refer one of the book I've read, Dashboard Design by Stephen Few, one of the good book. If you want to go into the more visualizations.
Acha.
Yeah,
What is
that
the name of that?
Stephen Few. Stephen Few.
Stephen Few.
Few. Yeah.
Spelling, last name?
I believe PHEW.
Yeah. Stephen Few dashboard. Art and science effective. Okay.
I've read that book long back ago, 5 years back actually.
Okay. You like
But
the
this
book?
is, yeah, that is one of the good book. How to design anything.
Yeah, actually, there's in fact, I have put one in your Tableau. There are some videos also, and there are some resources which you can explore. I found one resource very useful, which was basically by Tableau itself, where they had talked about how to present your data. So I just open it up once for you because it's a good way of looking at the design aspect also. It's a white paper by Tableau. It should be there on the link. It's called a visual analysis guide. I'll just share that screen. So this is the Tableau workbook, which is I found it, which Tableau has themselves suggested as how to make your charts look better. And they have given some good examples also how to, like say for example, this was the chart, how this chart can be improved better by creating these, breakup of the colors and creating helping you to distinguish between the different types. So they've given some nice examples of how these charts can be improved further, and which type of chart is most suitable in what context. So you can read this also, how to present data, and they're given some do's and don'ts of when to use what type of charts. Which chart is good for what type of data. So these are correlation for quantitative data. Like if you have two quantitative data, like I want to look at a correlation between price and quantity. Like you have that if the price drops, like how in economics we have that if you drop the price, quantity demand grows up, which means there's an inverse relationship between price and quantity. The higher, lower the price, greater the quantity, higher the price, lower the quantity, all other things kept equal. So you can create this kind of a correlation table, correlation scatter plot basically. So whenever you have quantitative data, like as I have mentioned here, that you have measures, two measures, then I can use this kind of thing. Then where to use whiskers, clocks, etc. Okay, so you can maybe go through this also, and I'll also see if I can get time. I'll go through that book if it's available to refer. But there are many good references I have with me also with on this whole storytelling with data, how we can make it even, how the storytelling with data can be done in general. Okay, so let's go to some more. Let's go back to Tableau. Here, let's now try to. So if you now want to create a new sheet, so the idea is in one sheet, you can probably play around with maybe a few dimensions and measures, like maybe one or two dimensions, one or two measures, but that's about it. especially measures should be one. Like you look at one measure, like either a sales or a quantity or a discount or a profit. You take one measure, maybe 2, 3 dimensions you can put. Like for example, now in this chart, okay, there is something called, as I said, right, that there are categories now. We have these office supplies and categories. So let's try to make this chart with one more measure. So let me just replicate it. So let this chart be as it is. So what I'm going to do is I'm going to create a sheet too. So this is the, there are 3 plus signs. One is to add a new work sheet, one dashboard and a story. So we won't maybe go to story, but at least worksheet and the dashboard should be good enough. And anyways, I said a lot of times we present our analysis offline in a workbook context, in a, sorry, PPT or something like that. So we will use that. So now what I'll do is, I'm trying to bring in one more aspect, one more dimension into picture, sales across regions and category. Okay, so that's my objective. I want to also now examine. So I have found out from this chart that there is a sales happening spread out across these regions, where the western region is performing the best and contributing the highest, and south is contributing the lowest. Now let's also see between these 3 types of products which we have, which are your office supplies and furnishing, which is what comes in the categories column, how they are split up across these different regions. We'll see that aspect. So we are looking at adding one more dimension to our entire region, which is already there. So we're splitting the data now based on 2 keywords, the region and category. So these are our 3 categories: furniture, office supplies, and technology. So we are just going to add that thing. So I'll show you how we can do that in a, across. Sorry, I just want to reduce this. So one thing is that maybe you can just keep the name short, sales, like region, categories here. You can always double click over here and even delete this, and you can write a simple sales across regions and categories here. And that can be a separate thing, because that is like your own whatever title you want to assign to this particular visualization, and that becomes your main. That cannot be necessarily, has to be always whatever is the workbook name. Okay, so let's take sales and put our sales in the rows, which means it will come on the y-axis. So on the y-axis, my sales already come. We have the regions, which is my qualitative field, and I'm putting it into columns, so I get the same chart. Do the same small tweaks, like spread it out, add these sales into my label also. So the label text field comes so that I can see it. And now I'm adding one more dimension, which is my regions. So which is my region here. Instead of taking it and dragging it maybe here, which will give me some kind of different picture. Sorry, not region, sorry. I'll remove this, sorry. Category, where is my category? Here, category here. So one is this kind of a breakup, which is where now you have split the data into 2 sections. One is region wise, and within each region, category wise. So you're getting like this kind of a bar chart. Another better option is, another way to present this in a more nicer way is take that second new category, instead of dragging it inside the XY columns, you put it into the colors. So now you have within that same 4 only, you can see the breakup nicely. So you can see that these 3 legends have come up automatically. One is for furniture, for office supplies, and for technology. So this gives you a little more compact, nice view. By looking at these numbers, now you can see which ones are where, and you can again put it into top to bottom, and you can get to see this breakup. So this is one type of presenter. Have you been able to do this? Should I wait for 2 minutes or should I go ahead? Just get this on your screen, then I'll just proceed. Are you all with me here?
Yeah, yes, Professor, yes.
Okay, just I'm giving you 2 minutes. Just look at the data. Just do this thing. What we did. And anyone who has not understood or wants me to repeat any of the steps, please let me know. I'll redo it. It's very simple to do it. So please don't feel shy of asking as many times as required. I'll be happy to, because it's an online class. So I can't really figure out whether you all have understood or not, because in an offline class, you can just see the people's face and you know that they've understood or not.
Professor, sorry. So our project will be something like this. We will have to create something like this.
Absolutely. What we'll do is, after I finish a bunch of visualizations, we'll just open your project sheet. There they have defined the scope of the problem statement. They've already defined it for you. But your job would be to examine the data set, what is provided, and come up with your insights in terms of what are the different elements in terms of how that problem. So we'll go through the problem statement once today, once we finish few more of this practice data set.
Okay, thank you.
Sure.
Can you tell me once again, like how to add a category?
How to add a
category in the
category.
marks?
So I'll just go back once just for your reference. So this is a back window or undo button. So you can just go back and I'll undo everything. So this have you been able to do the first set of activity?
Yes, sir. Yeah.
Okay, great. So once you have got the basic, regions and sales along with the tooltip, the label on top, which is what this label gives you. Okay, this presentation of this data without having to move your tooltip. The next thing is whichever next you want to analyze. Like I want to look at sales across regions, which I have done, but also I want to see the breakup of these three categories, how that breakup is happening within each segment, within each region. So what I've done is, this is my variable, right? Category. This variable, I'm dragging it and dropping it into the colors section of this, what we call as a marks card. So what it does is it just splits this data now category wise. So you can see that it has run a query at the back end where it has said that select the sum of the entire, like for example, if I show it in Excel, it will become easier. Now this is my Excel sheet, which is my pivot table, right? Now in this, I'm adding category as one sub dimension in my rows. And now I can see that these are the breakup, or if I put it into say columns, I think it's better. So now in central, now we have the split up across these three categories. So this is these numbers. I'll just format it once. Just remove the decimal places once so that you can get the number. So now central region, these are the three values. 1673767 is the sum of sales for furniture. And this is what we see here, 163797, whatever the number is. Then if you, so if you see that central office supplies 167026, that is this 167026. Now, how does it calculate this? Now, if you just double click on this, like how we can just see, it has filtered the data. So what filter it has applied? As I said, region is only central region. So if you just want to cross verify, you can see that this is a filter which is applied where only region filter is there. And in my category also, only office supplies is there. So this sum of this whole column, this particular entire column, the sum of it, what you see on the down here, 167026, that number is what we are seeing here. That's the power of summarizing aggregations, basically what we're doing now. We are collating all the data which is matching our criteria, which are our dimensions here, which is the region and the category, and collating the sum of the sales, because it's a quantitative field. You can do sum, you can do average if you want to look at averages, if average is a better number, or you can look at any of these things. The same thing we also can do it in your pivot context, no? Where we can create in this also, no? In our sheet here, this sum of sales, this formula we can also edit it and make it so sum count or average or whatever it is, mixed one. So that is the basic concept of this dimensional modeling, that we combine some qualitative and quantitative fields and get the aggregated view of what is happening across a large number of transactions or database entries. So is this clear now? So this is the basic logic. Now, as I said, it's an exploration process. We don't know what we will get unless we try out all the different scenarios and work with all the different dimensions and try out different combinations of dimension measures. And we don't have any presupposed idea that we are aware of. So we are just exploring this whole thing. One other way we can also explore the data is if you, like, say, for example, I want to just look at this field. Now, the moment I click it, you can see everything else has got filtered. So there is an option called keep only or exclude. So the moment I select something, like say so one thing is, now this panel is a little interactive because these numbers are picked up from the backend. Now I can just click on this and choose to say exclude. If I exclude it, it will filter out that portion. So this is just to help you to on the fly interact with this particular thing. But when you say keep only, so if you see all this, whatever filters we apply, it gets created as some filters basically, and these filters have some rules which you have set, right? That don't include it or include it. According to that, these filters get created. So just take a minute to, you can also press your control button and maybe just select whatever you want to keep. And all you have to do is hover your mouse for a few seconds, and then this option opens up on top. Whatever you want to either keep or exclude. Like say, I want to keep this. The moment you take your mouse, it will not come, but in a few seconds that this window will come. So you can, if you don't want to get distracted with too many colors and too many subset of data, then this can become another way to interact with this Excel with this Tableau presenter. And as I said, whatever you have ticked, unticked, all of that is getting created as rules which are being used for filtering the data into in the filters tab. So this is again a very easy to use interactive sort of way of using this concept of keep only to keep. So you can also use it here. I can just select this and say keep only. So if I or filter or exclude. So if I say technology and I say keep only, so only now I'm looking at the technology product category across these regions, and you might get a different picture. Right?
Yes, sir. I have one question. Like in my screen, numbers are not showing.
Yeah. So if the numbers are not coming, basically this label you have not added. So this is a label we need to add. For that, what it will do is take the sales field and drag it into the labels section on the left hand side panel. Then these numbers will start popping up.
Okay.
And you should see that whatever we are using as whatever things we are adding into our, they all become stacked over here. Like we have filtered the data on the basis of colors, which is what this color symbol is for the categories. That's why we have these three legends created for the three categories with blue, orange, and some other color. You can customize this also. It is editable. These numbers and these things. Similarly, we've added these labels so that these numbers are shown to us. And we can also do some filtering, or we can do some calculations also. Like, for example, we can add a quick table calculation where instead of looking at the absolute numbers, say, for example, now these numbers are a little hard to read and interpret. Now, if I ask you to interpret which category is most highly selling and what is its contribution to sales, you might have it difficult to explain it to me. So the best thing is converted it from absolute to relative. So we can do it as percentage of total. So this is the percentage of total, grand total. So you can just simply convert it into a percentage numbers. So this will tell you that if this whole thing is 100, then this is the breakup between that. That is one option. Or you can also you can move it to a percentage of column total. So I will show you that a little later because that will take a little bit explanation. But I'm just trying to tell you that the data can be presented in absolute numbers, which is an aggregation, or it can be presented in the form of a percentage format, which is good when you are comparing, when you want to make comparisons. Okay, so this is your second type of interpretation of your data. What I would suggest is let us first save this file because this is as we let's save the file and then move ahead. Now, as I said, I'm using the Tableau public version, so it won't allow me to create a local copy. But those of you who have already used the Tableau desktop, you can create a desktop version. Now, what I will do is I will log into my Tableau account and upload my thing there, and it will go there. So let me just enter my credentials. Now I have forgotten what my password is. Just give me a second. I'll just retrieve my password. Just give me a second. It's already saved on my this thing now there. Yeah, I have it with me. Let me just read it. Go through my search history. I'll find it. The idea is that once you sign in there, then you can start uploading it there. Should I work? Asking me to reset it because I have actually already used the right. हाँ, ठीक है. The new password is okay. So I'll just share my screen now. So some of you are using the desktop version, or all of you are using desktop. Anybody using public here?
I'm using public.
Okay, you are using public, huh? Okay. Okay, so when you save this, okay, yeah, sure, great. You're also using public. So when you successfully sign in, right, then it will ask you that what name you want to give. So we'll give it like whatever we are. So this is your upgrade. So now this is the workbook which I'm going to publish, which is exporting it on the cloud. All right, so now I have my workbook uploaded also, and I can also change the settings. So like, for example, there is a show sheets option. So if this by default, they don't show that all the sheets, they just show the latest, whatever you're working on. But it is you, since we have done 2 sheets, we want to show both the sheets so that it can see the sheet 1 and sheet 2. So now when you click this show sheets, which is there in the settings tab, then you can scroll the previous sheet as well as the new sheet, which is your region, sales region. And there's also an option where you can either turn it on or off the visualization. So there are a couple of my visualizations which I've used it, but I don't need to share it with anyone. There I switch it off and becomes hidden. I mean, that visualization exists on my Tableau public, but is not visible to others. Whereas now this visualization should be visible. So if you just go to maybe just search for this profile on, you will be able to open this sheet. So I'll just put this on the chat box where you can also just enter this link, and it should take you to this page, my home page, where this new sheet of ours is accessible. So can you open this link? What is which I have shared with you? And that way you can also share your link with me or with anybody whom you want to share it with. So just try this thing, uploading the workbook with a certain name, and going to the settings tab and just checking the options there. And once you're ready, just let me know, then I'll just move ahead. Should I go ahead?
Yes, sir. Yeah, please.
Okay, okay, fine. So let's now try some more visualizations. So this is what we have to kind of explore. So let's think of something where we can say use a line chart. Typically, when we want to use some kind of you want to compare the different things across time, then that's a good way to explore the options. So let's try to see that also. So just one quick thing is that you can also just use the download option and download this particular workbook either as a Tableau workbook. If you have a desktop, you can access it. You can open the Tableau workbook file. Or like say, for example, if you want to create one PPT, you can just select all the sheets in which are relevant for that particular workbook. Now, in this case, there are only 2 sheets are there. So we select both the sheets and we click on the download option and save this file on our wherever we are wanting to use it offline in some kind of context. So we can that ways see how this thing can be exported into different file formats, be it PDF or it could be this, this kind of a format. So share it. One second, I'm just downloading it. So I'm putting it in a PPT format. So you can just open the PPT and then edit it and make your own modifications to it. So like this kind of a format file has got created where you have the 2 visualizations created as images on your sheet. So it's very good to kind of just use it in for your future whatever project or analysis where you will be combining some of these descriptives with with few more types of analysis on that. So some of your data visualizations you can pick up from the Tableau environment and some from your other environments, whatever else are useful for preparing your analytical report. Okay. So this is good. How to export these file into a PDF from the public version, even that is possible. Let me also, as I said, bring in some more variables. So let's look at, for example, the sales across time. So for example, now if I'm looking at the sales numbers, I'm interested in looking at each sales number and trying to see how these are performing based on the dates where we are ordering. So let's look at the order date. Now here, this is where I wanted to a little bit explain to you that this time dimension can be looked at both as a quantitative and a qualitative field. Now, here you can see that when I have dragged this sales and put it to rows, this particular rows, this particular sales has got created at the y-axis. And on the x-axis, I have my columns, which are representing the years. Now, this might not be the right way to present it. Maybe, no, this is a better way to present it. Yeah. So we have the time dimension on the x-axis and sales on the y-axis. This is right because you need to show the time on the x-axis and your y value should be your quantitative field. Now, this is telling you that there is a year-wise kind of a decrease and then sharp increase between from 2016 to 19. And right now, this is also, you can move it to a fit width kind of a thing. So it'll tell you this numbers. You can drag this sales and put it to the label so that you have the sum of sales. So now what this is telling you is, this was the total sales which are achieved in 2016. This is the sales which has happened in 17. This is the sales that happened in 18 and 19. If you want to verify it, I would always encourage all of you to keep switching between Tableau and Excel. till you feel that you are comfortable with Excel. Can you see the Excel book? The Excel book is
sir.
visible.
No,
Huh?
sir. No,
Okay.
sir, it is not.
Okay, this is not there, so I'll just open this one. My Excel workbook is in the yes, this is my Superstore. This is my Excel. Okay, so this is my Excel workbook. So we have created one kind of a visualization here. Now I'm just going to create one more pivot table on a new on the same thing on a new sheet. Can you see this sheet now? The new sheet?
Yep. Yeah.
Yes,
Okay,
sir.
great. Yeah. So now if you see this, now I have looked at this order date and I'm looking at these numbers for different, we're looking at the sales numbers across these different regions. So you can see that 2016, this is the numbers 37001. So this number is for 2016, the total sales made. Now, what is the formula applied here is sum of sales. Here also they have applied sum of sales. Now, this is the order date, 16, 17, 18. But the numbers are not matching. So I'm just thinking whether these numbers are shown as 37001. These numbers. So these are the numbers which are coming on the Excel sheet 37001 for 2016. Here the number. So let me first explain to you that there are two panels here. Can you see the public this thing, right? You're able to see this line graph.
Yes, sir.
Okay. So if you see here, if you go into the order date, okay, there are these two common overlapping panels. One is on the top panel, which is a blue colored symbol, which again has year, quarter, month, day, and then there is even more further breakup. And then on the lower panel also you have the same thing. Now the basic difference is that this is a discrete column. What this discrete means is that the sum of sales is not continuous. It is for each year, you will get a separate value. So let me just show you in a raw format. Like if I go back to my orders sheet and I filter the thing based on order date and I only select 2016. Okay, I select 2016. Now the total sales, what I make here, if I just do a raw calculation, it gives me that there are 1993 records which are matching with this 2016 date, and the total value is 484247, which is what you see here, 484247. I'm just trying to figure out what happened on the numbers here. What is the issue here? Oh, because here also I have taken these things on it. You see here. Sum of sales on, I'll just remove all these extra columns maybe. Let me just drop all this. It's created some new columns, so order date, sum of sales. Okay. Numbers are not matching, so I'm not sure. But anyways, you saw the basic logic, right? How we just summed up all the numbers, and this number, what you get here, 484247, that is the number which is the correct number, which is telling me that in 2016, there were totally 1,993 records, which are telling you that out of the total 10,000 records, 2,000 odd records were for 2016. And like that, if I change the date, order date, and instead of 2016, I make it 17, I will get the total list of sales which have happened for that year. And that number is again 470532, which is this number here, 470532, which is being rounded off as 470533. So this is telling me that this data is aggregated. Is not aggregated. It is for each particular year, and this thing can be then broken further. Like for example, if you press this button here, you can show both, or you can just remove year altogether and just make it quarter. So there are 4 quarters, right? So you can have quarter 1, quarter 2, quarter 3, quarter 4, and you can have for all only quarter 1 these numbers. Now these quarters are for across all, but if you to be more precise, then you might have to show year and quarter both. It will tell you that, okay, if I want to compare the each of these numbers, like say if I want to do Q1 2016 versus Q1 2017, I can see these numbers that there were 74,000 and here it has dropped to 68,000, and I can just do quarter to quarter comparison. And if you want, you can also apply your filters and show a filter for a particular quarter only, and you can remove, say, I don't want to see all the quarters. I just want to see 3 or 2 quarters or 1 quarter, and I can get to see different numbers. So, so this is just to tell you how these line graphs work, and that the data can be presented either as what we call as in what we call as a discrete form or continuous form. So this is an important concept to understand, that right now the data is being shown in discrete form. That's why it is showing as a actual number which is not getting cumulatively added, and it is showing it as a yellow as a blue colored option. If I go down to this part, now these numbers are getting cumulated. So 484247 was 2016. Then this number is should be cumulated. So the idea is we're getting to see a combination of both. So that's why then this number becomes a continuous number. And when it becomes a continuous number, then the color also changes to green. So so this is just to give you the difference between what is a discrete and what is a continuous variable. All right. And you can break this further down. So this ability to break things down further is there if you choose the option where it is you're choosing it as a discrete option, where you can break it down further and get quarter, month, and of course make then becomes a little complicated, but otherwise you can only put it month wise, then you'll get month wise comparison. You can drop some of this, you can just drag it outside, and you can just see quarter and month. So this is a analysis telling you how things have moved only for a particular quarter, a particular month, or across all quarters, all months. So this kind of a thing you can get if you select the option of a discrete option, which is the top panel here. If you go here, then in the lower panel, then your data moves from discrete to continuous, and then you are kind of going cumulatively. So you can see here, right? 2016 Q2, then Q4, 2017 Q2, Q4, Q3. You have kind of you're seeing the pattern across the entire thing. So are you getting this concept of a variable? The time dimension can be analyzed both in a continuous or discrete form, and according to that, I will decide whether to keep it as a. So in this, we are showing it in the green color. So green color, you should understand, is related to a pure quantitative field, which is like a continuous variable. A discrete variable is a qualitative field, which is like a categorical field, which is not aggregating the data. And you can also, as I said, do all these cross-referencing with your from your raw data also. just to understand. But idea is that you get to, see the summary view much more effectively here. And from there, obviously, your insights will come in terms of which quarters you see performance high and low. So, for example, you will see that in the Q4 quarter, you see that the sales go up in across the quarters. So there is in every year, whether it was 16 or it was 17 or 18, between quarter 1 to 4, the fourth quarter is the most good quarter for you in terms of sales. Okay. Any questions, any doubts on the ability to look at this date variable for the purpose of using this creating these dashboards, creating this line charts?
No, sir, nothing as of now. I'm just waiting to get the download completed. I'll do this myself.
Oh,
And,
wonderful. Okay, no problem. I think I have actually shared one link in the panel in that folder. So you can also just see anyway. I think Sachin has also put some link so you can get it across and try this yourself once. What I'll do now is let me just go to the projects part. Should I just explain go to the project once, because you'll have to submit it now by next week?
yes, sir.
Yes.
Okay, fine. So if you have taken a look at this project, this is the same project now that you are working as a consultant, have been approached by your product manager for an upcoming e-commerce startup in Hyderabad. This is the same project you're referring to?
Yes.
Okay. Same one, na?
Yes.
Okay, great. Because they have a bunch of different projects which they signed randomly. So I had taken this extract, but basically this is from your that whatever that interface, now what you have. I just copied it onto a Word file. So these are your KPIs. These are the metrics which, as I said, every business wants to track and will try to measure how good these metrics are. So the demand. So you have to understand each of these metrics very well, because they have a very important reference with regard to performance of that particular e-commerce. So demand is number of customers logging in onto the platform at any given time. The menu to cart is how much percentage of logins from whatever people logged into, how many of them put items into the cart. And then from those people who put the item to the cart, how many actually paid that and purchased and created a proper order. Because it might happen that somebody might just log into the site but not put anything into the cart. Or somebody might put something into the cart but not complete the order. So in a way, they're trying to look at this whole operations and try to see what is the number of percentage of people, where if 10 people log into the site, how many of them end up putting into the cart and how many of them end up. It's almost like a sales funnel where you start with some prospects and then go to leads and then convert. So something like that. You have a person logging into the site, person putting items into the cart, and then person paying the money and confirming the order. So as you have seen, right? Like a lot of times we log into the site and then we change our mind, or we put something into a wish list, or then we delete the item from there and we go buy it from somewhere else. So many reasons are there, right? Why people log into, they just want to see the price, or they just want to see the specification. They're not interested in buying right now. They just want to just go through the information maybe. So there may be so many reasons why customers are logging into the site a lot, but not placing as many orders. And that ratio and number, they might already know that there is going to be a dropout, but maybe they would like to see is there some kind of a metric of what should be the ideal, or what is the typical pattern of this over time. For example, now they are having some kind of a problem where they're seeing that some cities are doing fairly well, but some city like Hyderabad is not having a very good percentage order through rate. So this particular KPI is low on for this city. So this is my dimension and these are my measures. So the whole basic idea that I will explore the data and try out different visualizations by going through the data set. So the data set, understanding all the variables and then trying to work out a combination of variables will be relevant because that will give you those problems. And I think they have made your job quite simple because they've given you some very specific, I think, questions now, which they want you to sort of answer right in the questions. Let me just see. I think they framed all these questions quite clearly. So as I said, the initial part is what we had discussed: 5W framework, the spin model, the 5C framework, the issue tree, what we discussed. And they have also given the time dimension that there are some orders which have happened in week 1 and 2 and some 3 and 4. And these are the visualizations they have given, right? So this is making your job simple because they have told you which are my measures and which are my dimensions. So this is one measure, the order through rate. Time of the day can become both a measure or a dimension, depending on whether you want to use it as a discrete or a continuous variable, like what we discussed about the time concept. And then they have asked you to do it for a city, so you can apply a filter on that. Look at zones because that might be one more variable. So just go through your variables and see all these, whatever terms they are using, you will find one column for each of them. And then you play around with the different options of XY variables on the X-axis, and on the Y-axis, and on this you have the different visualizations. So you can just simply by clicking, like say for example, now I am on this particular chart. Now when I go to the Show Me tab, it is already showing me that this is a recommended chart because it is already coming in the discrete format. And it is by clicking this, it can convert the variable into a continuous variable. And you can see that this green and orange, what we were doing here, by manually clicking this dimension and measure, discrete and continuous here, sorry. The same thing, you can also do it. So you can see that these two types of line charts, there's a continuous line chart and a discrete line chart. The main difference being the variable is either aggregated or not. But you can also experiment with all these, whatever are enabled. So whatever you see here, like say for example, this is enabled or this is enabled. You will have to see which is the most appropriate chart for that particular type of data. So this is another very interesting chart. It's called tree maps. So tree maps can also give you another perspective of highest to lowest ranking the charts, how they are arranged, and how these charts get arranged in highest to lowest format. And that ways you can create something. So we will spend obviously a lot of time in the next class. The entire class we will go into all these different examples and present to you all these different, whether it's pie charts or tree maps or bubble charts or these box and whisker plots or even scatter plots, which is not enabled for this because we have a measure here. But if you had two only measures, then we can also do scatter plots also. So we'll do a bunch of at least 5-10 more visualization and then prepare a dashboard. In the meanwhile, you'll also experiment and explore these data set, what you have. And then I think by 1 day's time now, you'll get to finalize the answers to these questions. Ultimately, you have to solve this problem. So you'll have to come up with your analysis of what you think are contributing to this drop in the order through rate for this Hyderabad city. So you'll have to know that that's my ultimate objective, that I need to explain that what is contributing to this. Is it the time of the day, or is what other variables you think can be potential variables which are affecting the performance of this order through rate in Hyderabad? And all these visualizations will give you clues of how this can be examined that way. So this is your project. So obviously I am not going to do the project for you, but I'm giving you some basic cues on how you can approach any problem in that sense. So they have made all these things quite easy for you because they've defined the problem. But in a real world scenario, you'll have to start with your problem definition itself, because that itself is not easy to arrive at. Is this fine now for now, or you want me to proceed, or show you some more visualizations, or keep it for next class?
Yeah, Professor, just wanted to know, so at the end of the project, it is similar fashion, right? So we have to kind of record the screen, or we just need to, how do we present?
Yeah. So there is something called, they have actually put this, they have 1 minute, there's some template also, I know. There is, I don't know how it will eventually look like. This is like an offline version which I have, but eventually each of these things, let me just give me a second. There is a project submission template. I'm just opening the template for you. Can you see the screen now?
No, sir.
Okay, 1 minute. Let me just stop sharing it. So this is the breakup of this 40 marks project. They have given the, now you're able to see, right? This evaluation sheet.
Yes.
Yeah. So this is the breakup of marks. So the initial, you can say 2, 4, 9, 13. So the 13 marks have been kept for the conceptual part. And then 14 marks is for those different visualizations. So they have given the, so, they have given the requirements of what all they want you to complete in each project, in the project. And in that sheet, anyways, in this, for example, here in this sheet, they are talking about the various types of examples now they want you to run. So here, right, we have seen these now in this 14 marks, question number 5, A, B, C, D, E, and F. There are 7. 7 into 2, 14 marks is allocated. So there are 7 visualizations you need to create between A to G. Okay. And for each of them, you'll have to copy paste it and put it as a screenshot. Once you have completed the Excel workbook, then you download it into PDF or PPT format and then paste it. And I think you'll have to upload it. So exactly.
Sorry, sir, for this question, you said we have to create different visualizations from A to Z. Where is that mentioned in the question?
So they have mentioned that for each visualization, add the screenshot of the visual to your project submission document. And this question number 5, you see the description on the which I have created offline, but this same thing is there on your upgrade site also. That these are the visualizations they want you to do. Order through rate at different times of the day for Hyderabad for all zones compared with other cities. This is A, then B, C, D.
No, that we are not able to see. Are you showing that somewhere, this A, B, C, D options?
Okay, 1 minute. This was the previous one which I showed you. 1 second. Let me just go through that. So this ABCD, this is the visualization part, which is there on your dashboard. I'm sure you'll find it. These are the options they've asked you. In question number 5, which is the main 14 marks question.
We are not seeing your screen.
You're not seeing
this?
Now
it is visible. Now it is visible.
Can you see this? A, B, C, D, E.
No, now we can only see the graph, the plot.
Tableau
sales, the sheet 3 you are showing right now.
Let me just share the screen now. Is this okay now?
Yes. Yeah, now we can see. Correct. Yes. Okay. Got it.
So this is our project all about. Our project is about this order through rate in Hyderabad. As I said, the initial set of the questions are on the problem solving part. But then the main part is the visualization part. And the visualization, there are 2 questions. One is question 5, which is 14 marks, and the question number 6, which is 7 marks. So that is 21 marks basically. And in each of them, they have put the breakup. For example, in this 14 marks question, there are 7 visualizations, each visualization carrying 2 marks each. Okay, so your job is to identify the right visualization, that is point number 1, and then interpret the information. So one is A is telling you order through rate for different time of the day for Hyderabad city compared to other cities. Then B is telling you. So these are all the different variables which are there in your Excel workbook. So you have to create these multiple sheets in your Excel, in your Tableau or desktop or public, whatever it is. And then once you finish making these charts and you have selected the right charts, then you can copy paste these visualizations in your project sheet, wherever you need to submit it online, but you'll have to paste it. And I get a PDF version of it. So I just get a downloaded, like a assigned project PDF file, but all these things will be pasted on that. So I'm not sure how they do that entire thing at the back end, but basically the faculty, whoever is evaluating a project, like in this case, I'll have to evaluate. I'll see your visualization, and I'll also read your interpretation, and I will give you 2 marks for each, for 1 mark for the visualization, 1 mark for your interpretation, which is your takeaway.
Understood. And we will only create the PDF, sir. I mean, based on my last experience. So what we do is we put it here and we save it as a PDF. And then what I was asking is, in some previous projects, what we had to do is we had to download another tool, which is a screen recording tool. And then we explain through the project, and that screen is getting recorded. So that also we have to do here? Or?
So, yeah, it is there. So to see the breakup of the questions, in question number, the video partner, when you have to create a video, that last question is 3 marks.
Okay. Yeah.
So,
same thing.
So the main thing is the presentation of the data based on those visualizations which have been described in the project description sheet, where they have told you that run these analysis and present the data, create the screenshot and your takeaway. So for 2 marks per visualization, means 1 mark for the visualization and 1 mark for the analysis. This is one part of the visualization. The second part of the visualization is they just want to look at the quantitative fields. So these are the quantitative data, as I said, right? Scatter plots. So correlation are basically good for XY analysis, where on the X and Y, both there are measures, no dimensions here. So delivery time is a measure. Order through rate is a measure. Delivery charges are measures. So all these are your quantitative fields. The hash symbol, what you see on the, which you will see when you upload that into your Tableau environment. And all of them are filtered for Hyderabad city. So you remove, if there are other cities, then you filter out all of them and just say that Hyderabad, and you proceed with that. Anyways, we will do something on these lines in the next class so that you will become more familiar. So try out in the week, and obviously by next week, as I said, it's you will be much more familiar and comfortable with preparing these kind of,
so we have to submit the project before that, I believe.
No, you have to do it after that, I think.
After that? Okay.
I think your project submission will happen 1 day after my class. So maybe by Sunday, I think they might ask.
Okay, but yeah, we won't have the much time left.
You won't have a lot of time. You will have to work on your own. So there will be some of your self required. But as I said, you can start off over here and also experiment with the data set. And in the next class, where of course we will use some other data sets, but we will try out all these visualizations for both qualitative and quantitative data. And then here they've made it your job very specific. They've told you what they want you to do. Like they want you to do correlation, so you need to do scatter plots. In others, you will have to check whether you want to use bar or line charts. So which charts look best in a given scenario. So you will have to experiment and see these different options, and then see which ones are more suitable. And here, as I said, they have also asked you for interpretation. So you have to close the loop in terms of showing the ability to create a chart in Tableau, and also interpret those numbers, whatever comes from that. And finally, as you said, right, we have to create a video. So there is a video part, which is the whole project. You explain it in whatever 10 minutes or 5 minutes, whatever time limit you think is needed. Yeah, 8 to 10 minutes video. So this is a PPT. So as I was talking in the previous class, right, this pyramid storytelling principle means you start with the main insight and then go into the subset of the insights. So start with the main insight and then all the other supporting evidence to support that. So the main question what they have, right, is why is there a drop in the order through rate in Hyderabad? That you have to explain it in the first slide, and then you can talk about how you have how you justify that your interpretation of the reasons why Hyderabad is underperforming with regard to the order through rate. And these are the criteria for evaluation also. So 5 marks for 5 C's, but for 5 W, they have given only 2 marks, but it's okay. These questions are again going to be asked for in your end term exam also. So you will have these, you'll have to use them even later. So this is only 40 marks. So 60 marks is anyways your end term paper. So there also you'll expect no analysis or no visualization, but all these things will be having higher weightage in the end term paper. Okay.
Okay. Thank you, Professor.
Okay. So we'll see you in the last class, and we'll deep dive into the Excel into the Tableau's different chart options. Right, we have seen a couple of charts, but we'll go through at least 8-10 more different visualizations using the different options given, like tree maps and pie charts, obviously scatter plots, blocks and whisker plots, or some of the geographic maps, which are also very interesting maps, geographic data point, how to present the data using the geographic fields. So thank you, and see you on the 22nd of 22nd for the last session of us.
Sure,
Bye.
sir. Thank you,
See you.
sir.
Thank you, Professor.
Thank you. Bye-bye.
Good day. Bye.
Thank you, sir.
Bye-bye.